Hi, this video is a sequel to Methods of Laplace Transform and Partial Fraction, example 2, part 1. Alright, so this is a continuation. This is the part 2 of that video. So in that one, we discuss and solve this equation. We were able to find for x bar, and in this one, I am taking the solution for y bar. Alright, so let's continue from where we ended. So we were able to eliminate y bar and solved for x bar. This time we are going to eliminate x bar and solve for what? Y bar. So we have two equations here, equation 1 and 2. How do we eliminate x bar? So these are the two equations on that first paper, and we have x bar here, 3x bar here. If I open bracket here, this will be 3s x bar minus 3x bar. Okay, there is another 3x bar here, so I can eliminate this one and this one, which is this negative 3x bar. Okay, so to be able to eliminate this x bar, this 3x bar, I need to add both equation 1 and what? 2. So let's do that and see the result. So you underline this. I don't want to do this in a lengthy form, so I decided to write both equations up and down. So once we underline this, we add equation 1 and 2. So this plus this. Okay, so let's do it one by one. Now we have, let's expand the bracket first. So we have x bar here times this, giving us 3s x bar. We don't have an s term here, so we can maintain this one. Then we move on to x bar times negative 3, giving us minus 3x bar. We have a term here that is the same, so we add it, plus what? 3x bar. Okay, then from here we can multiply this and this. So this is plus 2sy bar. Okay, but we don't have an s term here because there is no s in equation 2. So I'll continue. This time this will give me minus 6y bar, and I have a term here that is the same, so I'll add. The equation said we should add, so when I add negative 2y bar, the result is still minus 2y bar, equal to, we have 6 plus this 3. Okay, so I have added both equation 1 and equation 2. Now this one can cancel this to eliminate the x bar. So now the equation becomes 3s x bar plus 2sy bar. This and this will give us minus 8y bar, giving us 9. Okay, so now I am interested in y bar, so I'll carry 3s bar to the right side. So this is giving me 2sy bar minus 8y bar equal to 9 minus 3s x bar. Now let's label this equation 5. Now watch very carefully. Now there is also x bar here for us to eliminate. We are not done yet. So because of this one, I need to go back to the two main equations that we generated during the calculation. If you look at the first video, this was equation 1. So from simultaneous equation, I use the equation 2 to solve for x bar. So this time I have to use equation 1. Okay, so now when we look at equation 1, we have something here, which is 3x bar. And when we look at our new equation 5, we have negative 3s x bar. So what do you think we can do to equation 1 to be able to make it the same as equation 5, so we can eliminate this side? So to be able to do that, we need to multiply equation 1 by negative s, so that we will have negative s 3x bar, which will be similar to this. Then we can either add or subtract to eliminate the x bar term. Do we understand? So now when we multiply this equation 1 by negative s, what are we getting? So we have minus s 3x bar plus minus s. We have 2s minus 6y bar, giving us 6 times minus s. Okay, so let's expand this. We are having minus 3s x bar. This time this is giving us minus 2s square y bar. There's y bar term outside here. Then when we multiply this, we have plus 6s y bar, giving us minus 6s. So we can label this one equation 1 star. Now the same way I move the x bar term to the right side, let's do the same thing here so that we can maintain this side. So we have negative 2s square y bar plus 6s y bar, giving us minus 6s plus 3s x bar, which is equation 1 star. So now we can call equation 5 and equation 1 star and add the result so that we can eliminate this side. Do you get it? So our aim is to eliminate this and this so that we can make y bar the subject. So let's do this on a fresh sheet. So now let's add both equation 5 and equation 1 star. So let me put my addition here. I'm adding both this and this. So I think the way I've been adding it, I don't know if you guys are getting it. So this time I'm gonna add it straight because I have a broadsheet. So we start with the s square term. We don't have an s square term here, so we have minus 2s square y bar. Let me add it to this, plus 2s y bar. We move on to this one, plus 6s y bar. We add it to this one, minus 8y bar. Remember that this negative will overshadow this addition sign, so it is the same as plus into brackets minus 8y bar, which is still the same. Then we equate it to negative 6s. I add it to that one, plus 9. Then plus 3s x bar. I add it to this one, minus 3s x bar. Now, do we get it? This will now cancel this, and we have now been able to eliminate it. Okay, so now let's group this very well. We have minus 2s square y bar. Watch, this and this are the same. So we have plus 2 plus 6. We have 8s y bar minus 8y bar, giving us minus 6s plus 9. Okay, because I want to make y bar the subject, I want to avoid this negative, this one. So I'll carry everything on the right side to the left side and carry this to the right. It's the same thing, okay? No matter how you do it, you still get the same answer. So when I carry everything here to this side, I am having 6s minus 9, giving me, when I carry this, I have 2s square y bar minus 8s y bar plus 8y bar. Okay, then I can factorize y bar out, giving me 6s minus 9 equal to y. Well, let's hold on. We have a common factor here, which is 288. So we can bring out 2. So let's factorize 2y bar out. So 2y bar outside. This is giving us s square minus 4s plus 4. Okay, so now we have a quadratic function here. So we will get a repeated factor. S1 equal to 2, S2 equal to 2. So when we cross this, we have S minus 2 equal to 0. Then this one, S minus 2 equal to 0. So this is a repeated factor giving us S minus 2 all squared. So we can substitute it here. So we have 6S minus 9 giving us 2y bar into bracket S minus 2 all squared. Now we need to make y bar the subject. So we divide through by what? 2s minus what? 2 all squared. So we do the same thing here. 2s minus 2 all squared. This will take care of this. This will cancel this. Okay, so now we are left with 6s minus 9 out of 2s minus 2 all squared, giving us y bar. Now we can switch y bar into partial fractions and solve. To resolve y bar into partial fraction, you see these two, I'll factorize it out. It's the same as 1 out of 2. So this is the same as me saying 1 out of 2 into bracket 6s minus 9 out of s minus 2 all square. Okay, this is not really important. We'll use it to multiply the final result. Now we switch this side into partial fraction. So this will give us a over s minus 2 plus b over what? S minus 2 all square. So this is now in partial fractions. We need to solve for the constant a and b. All right. For this 1 out of 2, I can put this in brackets and bring it here, but let's focus on this side. When we finish, we'll bring it back, okay? So first, when you take LCM here, let me do that for you. The LCM is s minus 2 all square. Now, s minus 2 here will cancel one of these because this is the same as s minus 2 times s minus 2, okay? Once it cancels, we are left with what? A at the numerator times the s minus 2 that was left, okay? Then this will cancel this whole function. We are left with 1. 1 times b will give us plus b. So our equation becomes 1 out of 2. Let me bring it here. A s minus 2 plus b all out of s minus 2 all squared. Now compare the right hand side and the left hand side of the equation. This and this are the same. Since we have the same denominators, partial fraction says we should equate the numerators. So the numerator is s minus 9, and this side we can equate it. For the 1 over 2, let's hold on for now. So our y bar equal to 6s minus 9, giving us what? A into s minus 2 plus b. Now you can use cover up method to solve this. Okay, decide on what you want to do, but I will not use cover up method here. I'll compare coefficients, okay, so that you know the two methods. So now I can expand this side of the equation by having 6s minus 9 giving me a times this is giving me a times this minus 2a plus b. Okay, so I'll group like terms. I'll put everything here in one bracket. So we have 6s minus 9 giving me as plus minus 2a plus b. So this side becomes the constant. So now we can compare the left hand side of the equation with the right hand side. We have a to be equal to 6 and minus 2a plus b to be equal to what? 9. Now when you compare the left hand side with the right hand side, we have 6s equal to as. Okay, we can divide through by s to make a the subject. So a is equal to 6. This and this are the same, so there's no need. All right. Then when we compare again, what are we having? We have negative 9. Negative 9 is equal to what? Minus 2a plus b. But we have a to be equal to 6. So we have minus 9 giving us minus 2 into 6 plus b. So this is giving us minus 9, giving us minus 12 plus b. So this equals negative 9. When you cross this, plus 12 equal to b. Therefore, b equal to 3. Okay, so now we can come back here and substitute the value of a and b into this equation, this side. Okay, then we introduce our 1 out of 2. Don't forget we left it. So this is giving us y bar is equal to 1 out of 2. We have a to be 6. So we have 6 out of s minus 2, then plus 3 out of s minus 2 all squared. Okay, so now that we have been able to substitute the value of a and b, we can find the value of y by taking the Laplace inverse of this whole solution. So we take the Laplace inverse of y bar, giving us 1 over 2, the Laplace inverse of 6 over s minus 2 plus 3 over s minus 2 all square. For this 1 out of 2, once we get the answer, we use it to multiply. Then previously, I told you that the Laplace transform of the exponential function e to the power at equal to what? 1 over s minus a. So we are having s minus 2. So this 2 becomes our scale representing the variable a. So I can substitute 2 with what? A. We have 6 here, so we can factorize it out, and we can factorize this 3 out to have 1 at the numerator so that you don't get confused. So you can rewrite this by saying 1 out of 2, the Laplace inverse of 6 times 1 over s minus 2 plus 3 times 1 over s minus 2 all squared. So that is it. So now when you take the inverse of this one, this is a constant. Do not take the inverse of the constant, okay? There is no need. So when you take the inverse of 1 over s minus 2, what do you have? The result is e to the power what? 2t. Remember that if this side is negative, this is positive. If this side is positive, this side is negative. So this is multiplying 6 plus 3, okay? Then when we take the inverse of this, forget about this square. When you take the inverse of this, we are having what? The same e to the power what? 2t. Now, there is a square here. Because of this square, put t here. This is coming from the rule of Laplace transform, multiplying by t. Multiplying a function f of t by t. And it involves a lot of explanation. So because of this square, put t here. If you don't put t here, you are wrong. So now everything we have is multiplying 1 out of 2. So our final result is equal to, so now the Laplace inverse of y bar will give us y. So y is equal to whatever we have here. So we have 1 out of 2. We can put this in a square bracket. 6e2t plus 3te2t. And this is our final result. So this is how you use partial fraction and then the inverse of a Laplace transform to solve for a given differential equation. So this is Daniel. I will see you in the next one.